Friends, today we'll discuss about functions of 12th class. Okay, of class 12th. So before discussing about the functions which are in 12th, let me recall the meaning of function. What is a function? Function is a relation. Function is a relation from a non-empty set to non-empty set, suppose A, to a non-empty set, suppose B, such that there is a condition such that the domain of the function f is A and no two order pairs of what? Order pairs in the function f, no two order pairs in the function f have the same first element. I repeat, this we have discussed in 11th class. A function is a relation from a non-empty set capital A to a non-empty set capital B such that the domain of two functions f, the domain of function f is A and is capital A, and no two order pairs in function f have the same first element. That is, the meaning of this is every element of set A, every element of set A has one and only one image in set B. Every element of set A has one and only one image in set B. Clear? Now, there are many you can say special functions that we have completed in 11th class. One is what is real valued function. What is real valued function? Another is real function. A little difference between these two. Real valued function means function has either R or one of its subsets as its range. Remember, has either R or one of its subsets has its range, whereas real function says function which has domain, function whose domain is also either R or a subset of capital R. A real valued function means related to range, either R or one of its subset or one of its subset, that its range, whereas a real function domain is also either R or subset of R. And we have completed what is identity function, constant function, polynomial functions, rational function, modulus function, singular function, greater than function. These functions you have completed and many more functions that we have completed in 11th class. Today we will discuss about types of functions. Many functions we have completed. Now what is types of functions? Here functions are of generally four types. One is one. It is also called as injective function. Another is many one. Another is onto function. Onto function is called your surjective. Another is your one and onto, that is called your bijective functions. First we will discuss about one function, that is your injective function. Injective function. Function is said to be a function is said to be one if the image of distinct each and every separate distinct elements of x under the function f are distinct. Clear? That means there is you can say function is said to be one if the image of distinct elements of x under f are distinct, then the function is one. You can write f of x1. If f of x1 equal to f of x2, it will imply x1 is equal to x2, where x1, x2 belongs to capital X. Clear? You can say like this also, mapping you can say. Suppose the set X contains the elements ABC, set Y contains the elements 1, 2, 3, A is mapped to 1, B is 2, C is 3. So this is your one function. Clear? You can say y is equal to x is a one function. Clear? What the value of x will take? Same value will get for y. Clear? So this is your one function. Now what is onto function? Many one function. Many one function. Many one function means if it is not one, that means suppose this is 1 and minus 1 and 1. So if you say y is equal to x square, then if when x is equal to 1, you will get what? 1 square is your 1, that is your y. It is many one function. Okay. That means many objects have one image. Many objects have one image. That is a many one. Now we discuss onto, that is your surjective function. The function is said to be onto if every element of y is the image of some elements of x. What the function? F such that x to y. If every element of y is the image of some elements of x. Clear? For example, you can say A, B, C, D. Here 1, 2, 3. 1, 2, and 3. One element is left. This object, its image is not present in Y. Clear? One more example you take. Suppose the function is q to q and x, y belongs to q. X is equal to 1 plus y. Okay, put the value of x as, then you will get the value of y as x minus 1 or 1 less. Okay, similarly, now we will discuss one question. That is, prove that, yes, if that is one left, that is your bijective function, the function which is both 1 1 and on 2, and that is called your bijective function. Now we discuss one question. Prove that the function f such that R2R given by f of x is equal to 2x is bijective, that is 1 1 and on 2. We have to prove. For 1 1, check f of x1 is equal to f of x2. F of x1 means you can get 2x1 is equal to 2x2. Then x1 is equal to x2. So the function is 1 1. Similarly, f of x is equal to x, but you know f of x is nothing but y equal to 2x. So implies x is equal to y upon 2, or y belongs to R. Now what is f of y upon 2? In the question, f of x equal to is given, replace x by y by 2. So 2 into y by 2 gives you y. So f is 1 2. Clear? Now we'll discuss one more question. It is f such that R to R f of x is equal to x square. R such that f of x is equal to x square. For 1 1, we'll check whether it is 1 1 or on 2. Which function it is? We have to check. For 1 1, take f of x1 is equal to f of x2. Let f of x1 means you can write x1 square equal to x2 square. So x1 square minus x2 square equal to 0. You will get x1 minus x2 multiply with x1 plus x2 is equal to 0. So x1 minus x2 equal to 0, or x1 plus x2 equal to 0. So you will get x1 equal to plus x2 or minus x2. Clear? But what should we get? x1 equal to x2, but here we are getting x1 equal to x2 and minus x2. The value of x1 we are getting 2. So it is not 1 1. Now for on 2, f of x is equal to x square is given, right? So y is equal to x square. X square means always greater or equal to 0. So y is always greater or equal to 0. Y is always greater or equal to 0 means no negative real number you will get in codomain has its pre-image in domain of the function. So f is not on 2. no negative real number in codomain, because x square you are getting positive, negative you are not going to get as codomain. So it's the prime domain of x. So f is not onto. Clear? You can go through the exercise 1.2. Thank you.